It is hard to believe, but we are actually at February 25th, our last meeting for the month of February. And we have a decently full agenda. So any announcements? We just had a release, so I doubt there's release-related news. Any last minute, well, I guess it's not quite last minute yet. Kubernetes or KubeCon-related announcements. All right. With that, it looks like Keith and Prashant are top on the agenda with adaptive concurrency.
Yeah, Prashant isn't here, so I'm taking this. This is basically a proposal that has been in the API repo for a while. Istio/API. The proposal is essentially to there's been a little bit of a history here. So there's a PR to try to add per host sort of circuit breaking configuration. And that PR was closed. Rama recommended instead that if we're going to enhance the circuit breaking mechanism, that we instead use adaptive concurrency control, which apparently is more robust in Envoy. My understanding, might be wrong, is that adaptive concurrency control is sort of the successor in some ways to outlier detection in some cases. So again, that could be wrong, but that's just sort of my takeaway after reading through the history. And the ask is to sort of see if there can be some approval amongst the community, especially POC, to move forward with the API as described in the design doc. And Prashant did a great job laying out the design here in this document.
Okay, for those of us who probably looked at this 4 years ago when it first came up, I believe, can you give a quick summary of how this algorithm does what it does? I think I get the idea, but I haven't spent more than 30 seconds reading what you're scrolling past. So.
Yeah, so basically, my understanding at a high level is that it uses the round trip time for a given upstream in order and describe and measures how that round trip time changes over time in order to better manage the number of new requests that go to a particular host in an Envoy cluster.
Okay, so it's latency sampling using some form of smooth latency sampling to assess whether the backend is overloaded relative to some defined value, I guess, and then using that to back off requests.
Yes, I believe so.
Okay. So is it first order or second order, right? So first order would be latency is not meeting expectations. Second order would be the rate of latency change is high, which is probably indicative of a cascading problem, and so we should back off.
I believe it's the second order based on the last read I had of the document. As cascading failures is one of the explicit use cases.
Okay. I mean, I'm all for elegant solutions to complex problems. Like we do the same thing in load balancing, like peak EWMA is kind of doing the counterpart to this, right, I guess?
Yeah,
it's trying to spread the load, and this is trying to like shed the load. Eric, I'm going to read your chats because you've obviously come this live. Okay. Does it have any effect on? Does it just shed load, or does it queue and back off?
I believe that requests that are keyed in after the service is exceeding the ideal round trip time that's calculated, I believe those requests end up getting retried to other endpoints.
So there's no actual total load shedding, or the retry limit will kick in, and that's the load shed. I guess I should read the doc.
Yeah, I worked on doing kind of a POC for adaptive concurrency at my last company, and I do think it's useful if you're trying to mix SKUs. But yeah, I guess there's just the other consideration there around additional 503s. But I do think it's useful to add into the API, essentially.
Wait, when you say mixing SKUs, I couldn't quite part what you meant.
By that I mean like mixing machine types, right?
Oh, okay. Yeah, okay. Yeah, I get
Google
you.
Cloud or Azure, and you run out of capacity for one SKU type, you can use a less performance SKU, but you'll maintain that same ideal latency, right, across
So,
the
like
workload.
so did you compare that to like EWMA? Like one of the specific advantages of EWMA and peak EWMA is it's a better load balancer across varying latency profiles for the same service.
Yeah, I don't have familiarity on EWMA, but I will say that is kind of the problem we were trying to solve at the time, mixing SKUs.
If you look at last week's meeting, I think it was last week, right? We had a whole discussion about making EWMA and peak EWMA available as a load balancer option in the API. Right today, the default is least requests, if I remember correctly, but someone feel free to correct me if I'm wrong, which is not as good a solution as EWMA. So, Eric, if your goal was to have a better load balance effect, and there's obviously a lot of similarity between this and EWMA. EWMA is probably a better option as a load balancer.
Right, right. Actually, that is what the conclusion we came to, is that we were looking for a better load balancing type instead of this. And at my last role, we had a lot of like alerting and metrics around retries that we didn't want to affect by using something like adaptive concurrency. So that was our consideration. I mean, I still think it would be useful to expose natively in Istio. So I think this is cool that this was brought up, but
Okay.
yeah.
So Prashant is the one, I guess, mostly pushing this, Keith, right? I guess you picked it up as well.
Mainly to help bridge the time zone gap in a lot of ways. I'm sort of sponsoring it, so to speak. I realized I didn't link the actual PR in the meeting notes, so I will share that. The PR for the API specifically. One of the questions that comes to my mind, or actually maybe, okay, I did share the PR, so it's there's not a PR open for the proposal yet. It all comes out of this per host connection limits discussion that is linked in the meeting notes. So if you can want to scroll through that, you can see some background. If the design doc gives thumbs up on the design doc to move forward, he'll move forward with the actual API design and implementation. One of the things I want us to think about is sort of the, historically we haven't been very eager to add things to destination rule. I'm personally in favor of not doing that any longer. I think there are too many changes in the ecosystem, especially in the era of AI, but also just as new load balancing mechanisms come out, etc. I think Istio should evolve to meet those use cases. So I'm in favor of the option 1 in the design doc here, and just making this part of traffic policy. So just wanted to make sure that we thought through that part of the proposal as well.
If you want to scroll to that bit in the doc, or I don't know, sorry, Mitch, you're doing that, I guess.
You're muted, Mitch, if you're talking. I see you.
Sorry, Chrome crashed on me, so I had to restart. Let me get that, pull that up. Option 1.
The one concern I do have, I'll mention, is that it is a lot. There's a lot of tuning happening here, which is a bit concerning. As I've, to the extent that I've looked at it, a lot of it does seem somewhat necessary to actually use the feature well. But it is a lot of new fields.
I know that we've talked about this in the past, and this is sort of the second iteration of this proposal. Did we have any sort of consensus around how we feel about destination rule being expanded, which has been, an infinite beta API and will be indefinitely beta, as opposed to formulating this as a gateway API extension?
So destination rule is V1. Proxy config is the perma beta API. And so in that respect, I don't think there's necessarily concern about putting new things in destination rule. The second part of your comment, I think, is the question, does this belong in gateway API versus destination rule? And my answer there is that this will probably never be in gateway API.
Yeah.
It's just too Envoy specific.
Well, notice I didn't say in gateway API core, gateway API extension. So that would just involve modifying the way that we target workloads.
Well, services in
I
this
see.
case. Right.
Yeah,
So
target services or routes, etc.
I see.
we have talked before, right? So the big hang up with destination rule wasn't gateway API or not. It was ambient and subset or not.
Yeah.
That was the big problem with it. If subsets weren't there, then it's just, hey, here's a bunch of stuff we want you, the data plane, to do when you talk to a backend, right? Mostly load balancing policy and stuff like this, a few other bits and pieces. There's nothing inherently wrong with that part of the API at all. And then it's just, do we want to adopt target ref? Because right now the only selection mechanism is host, right? If I remember rightly, or is there now? Go look.
There's no target ref, it's only host, you're right.
Yeah, so like it could be like we've adapted other APIs to add target ref, like Alt-C, right? We did that to make it gateway API ified. We could do the exact same thing in destination rule. That would bring it into the ecosystem, so to speak.
There are some complexities with that, I think.
I'm sure there are.
Even with some of the target ref resources, it's hard to separate sort of. First of all, there's the existing configs problem. There's a lot of ambient out there already using destination rule targeting hosts. We couldn't
get rid of host, right? That's clear.
Oh, for sure. I'm just, when it talks about moving forward, moving forward is a big. We can't do it incrementally, is what I'm trying to say. We have to sort of move everything over using target ref. And destination rule does have a lot. There's also the concept of merging, which gets somewhat complicated. I think we do have some merging logic for destination rule. And then lastly, the how do I say this? It's the way that and we've done this in the past. It's not always clear. It's like, oh, target ref only applies to waypoints or whatever. There's this inheritance problem that was actually an unexpected consequence, I think, of when we add a target ref to other resources. That becomes that could be very unexpected and concerning with destination rules. So not necessarily opposed. It's just it's fairly complex.
Yeah.
I guess
like it was
from the perspective of we are moving to a world where Istio is effectively a multi-proxy service mesh. It's already true as a baseline and ambient, but we can do a little bit of hand waving and say, like, clearly if it's L4, it's zTunnel only, or zTunnel only supports L4, whereas Envoy supports all of the APIs. As we start looking at integrating Agent Gateway more and more, rationalizing what works well is going to get increasingly difficult for our users. And so when I see an API like this that I'm pretty sure would only ever work in Envoy, We're effectively just forwarding the Envoy underlying API. We're not really doing much in the way of mutation. I wonder if putting that into an Envoy specific CRD with Gateway API targeting semantics would be preferable to taking destination rule, some of which I think is applicable to zTunnel, all of which is appropriate to Envoy, and some of which will make its way into Agent Gateway eventually, or already has. Like it's complicated.
I don't think I agree with any of that last part. I don't know how to phrase that better. So apologies, that may have been more aggressive than I meant to sound. But I think all of the Istio APIs today, like the Istio grouped APIs, they're all targeting Envoy. Like they're all explicitly designed that way. Destination rule, even the stuff that works in ambient, is all like a facade on top of Envoy configuration. Outlier detection, circuit breaking, like everything in destination rule pretty much is bound to the Envoy implementation. zTunnel does not read any destination rule, has no effect on it. And when it comes to Agent Gateway, it's got its own model, its own data types that I don't think translate well to destination rule at all. Which is one of the reasons why we said that the scope for that integration is pretty much, especially initially, going to be just Gateway APIs with some, I think for like off policy, whatever, you can figure out how you want to handle that. So I'm not opposed to. In my mind's eye, I see sort of as if we want to have APIs sort of for Agent Gateway, we would create Agent Gateway APIs, or try to put whatever we can in Gateway API. And where there are Agent Gateway specific things, we would either use the K-Gateway Agent Gateway CRDs or create Istio versions of them. I don't think destination rule or anything really nothing in the Istio networking group I think will ever be targeting anything other than Envoy, essentially.
It might be a little bit of a stretch for virtual service keys, but that is fairly generic.
Uh,
Well, let's put it this way: like we can make a decision about whether it should or shouldn't, but the capabilities for like HTTP route versus virtual service, right? Like the only difference really between them is composition and delegation, not functional capability of the actual underlying proxy, because all proxies implement regex matching and header matching and stuff, right? Like that's pretty generic. I think your point is much more valid about destination rule. I think we don't use anything in it in zTunnel. I don't think we use any of the locality load balancer setting stuff, which I guess in theory we could have. We might use client TLS setting. No, we wouldn't use that in zTunnel.
there is zero part of destination rule that applies at zTunnel, to my knowledge.
Yeah, I tend to agree. I'm just like that. So we should check it, but yeah, I think you're probably right. And that I think is as intended. So I think overall you're right in that destination rule is an Envoy API. I think we could reasonably safely say that. And maybe the documentation should just update to do it. I tend to agree for Agent Gateway, when it gets integrated, it will have its own API to configure its own things, just like destination rule is an Envoy API. It may push us over time to have a lowest common denominator API again, right? So people could move between those things relatively easy. But that's probably the remit of Gateway API to define that in the first place, right? And we're trying to be less in that game. So overall, I agree with what you're saying. We should check the details.
Yeah, I think I can wrap my head around making the original Istio APIs effectively Envoy specific or marking them, so to speak.
I don't think the Istio Gateway API or virtual service are. Right? They were prototypes for HTTP route and gateway
Right.
in the Gateway API, right? Very specifically prototypes for them.
Right.
They aren't really full of envoyisms at all. Quite the opposite, in fact. The destination rule is absolutely chock full of them.
Virtual service, I would say, and even Istio Gateway do have some envoyisms, and that's actually the gap that a lot of customers are looking for between virtual service and HTTP route. Things like fault injection, and the way that retries work. For example, the Gateway API budgeted retries has no analog actually in Istio. So there has been a diff over time. But yeah, I think we're in general agreement as far as the Istio APIs versus and what they're targeting.
So then that would mean that like things that exist only in destination rule today will not exist in Agent Gateway until their corollary lands in the Gateway API.
Or you use the Agent Gateway API itself for the equivalent effect.
Could be the extensions on top of the Gateway API, yeah. And we've been doing that, by the way, in Agent Gateway.
Okay.
Agent Gateway has a traffic policy API that has this type of stuff in it.
Yeah. Yeah, I guess I'm just thinking of having those APIs effectively bifurcated in Istio. Things like outlier detection are not very Envoy dependent. It's a fairly generic API.
I don't know about that.
I mean, we've got consecutive errors, interval. Those are. I can't imagine defining an outlier detection policy that didn't have that.
Yeah, like at a fundamental level, there's only so many ways these algorithms work, right, and give people the results that they want. Like, the nomenclature that people use and the structure of these APIs, if you go look across the proxy implementations, can be radically different.
Right. So some would only, in Envoy, it's like outlier detection per cluster, but you inherit a lot of the Envoy cluster semantics, for example. Nginx aren't going to have those same cluster semantics. And how do they think about the load balancing pool versus other things? Even among Envoy implementations, what you consider to be a cluster varies across gateway providers. So yeah, I think while the intent or the spirit of those features might be common across implementations, the implementation and API differences do have real effect. So we have to, I think, be really careful about how we go about trying to make a shared surface.
I guess I get the idea that implementations do have differences, but as far as like clusters are concerned for outlier detection, that's not surfaced into destination rule at all. There's no mention of cluster in that API today. So that's going to be an implementation detail. Certainly implementations differ. I totally get that.
Right, like in destination rule, it applies the attachment point is the cluster, i.e. the backend. In other proxies, some of this stuff is bound to paths, not to backends.
Routes. Yeah. That's the complexity. So it doesn't say cluster, but the fact that the binding is host implies cluster. And so you're not going to be able to do that in another proxy where the attachment point for policies are routes. In Gateway API, we don't even really have a thing, or we're just now recently getting a thing in backend traffic policy that lets you target a particular service or backend. That's where these things start falling apart in a lot of ways.
Okay.
Anyway, we're not new to the world of having an Envoy specific API.
No.
Our favorite worst API still lives on and will live on clearly for a while. So there's that. So Keith, you're saying your preference is to just put it in here into traffic policy inside the destination rule?
I think so. It's better than the other option. It's the least worst option. Like there's a lot of stuff in here. I'm not thrilled about all the knobs.
Yeah,
But
yeah.
all the knobs that I looked at, it's like I can easily imagine a user wanting to have it exposed. So um, I think it's probably worth just essentially making it a pass through. And then to Mitch's point, I think this is a really good point. Like we do need to, be thinking about how we want to think about our APIs in a multi-proxy world. I know initially with the agent gateway work, we said that we wanted to make it only gateway API. Maybe depending on, because I've seen lots of people interested in it, you might want to look at that again, and consider if you want to limit ourselves in that way. I don't know, but I think defining that is going to be really useful for us in these conversations moving forward.
Yeah, and it doesn't need to block this particular work item. Like it just sort of raised questions for me. It probably would be good for us to imagine, what does Istio look like in 2 years? We're bringing in different proxies as different tools that are good at different jobs. How do we help our customers think about which tools are right, and to what extent are we abstracting over those tools, and to what extent are we exposing those differences and requiring them to think about that infrastructure? But those are much higher level questions that need to be answered for this pull request to move forward.
Yeah. Okay, yeah, I mean, at face value, this seems reasonable, fairly non-controversial. Might be worth probing to see if people are trying to achieve the same effect as EWMA, right? Which seemed to be what Eric was trying to do. So maybe that's also what Prashant is trying to do. Maybe not, right? Maybe they're trying to do load shedding. Both are totally valid. That would be my only real feedback, right? Are we appropriately targeting the use case? With respect to the API, I have not a lot to say.
Yeah, I think the use case is load shedding because there specifically was wanting to have per connection limits per host, which I think is more in that load shedding category.
Connection request. Usually we would be talking load shedding, we'd be talking requests. Which is what I would infer from something like max concurrency limits, right?
Yes.
And I see request counts, right? So that doesn't look like
It's not going to be measuring TCP latency.
That's true. I'll double check and probe him on that. That's a good call out.
I do want to make sure that we note what Liam shared in the chat as feedback. It says we're unable to migrate to the Gateway API because of the functionality gap from the Istio Gateway API. Liam, just out of curiosity, we've been able to use the APIs in tandem, where you might use Gateway API to define most of what you're doing, and then use a destination rule for the bits that haven't made their way upstream yet, so to speak. Is that also non-viable in your use case? Or is it just you'd like to stay in one class of API or the other?
I would need to go and look at exactly what I looked at this like 5 months ago, so I can't remember exactly what the functionality gap was, but yeah. Okay.
When I hear feedback like that 5 years after the launch of the Gateway API beta, I worry about how many of our users is it ever going to be realistic for to move to this. We want Gateway API to be a standard. We want it to move slowly and be a shared standard that a bunch of different services can adopt. And those are excellent goals. But if it never gets to the point of enterprise maturity, I don't know if that really is helpful to the industry. I guess it could be helpful for net new users, because oftentimes these features have been adopted because they exist. And if they hadn't existed in the first place, there wouldn't be a migration problem. But certainly, I'll say, like in my exposure to users here at Microsoft, I'm seeing a lot of, we're using various stuff that is not quite considered legacy, but we're not able to move on to a lot of different new standards because of lack of various feature support that we've adopted from the old standards. And that's true of Ingress APIs, that's true of Istio gateways, the Envoy filters plays a role there as well.
Yeah, the gateway APIs are not carrying all the water all of our users require. I think that's well understood. All right, I think have we hammered on this one enough? Should we move on?
Yes. All right, next up is, let me try that again. Next up is Jacek with cross-network egress gateways.
Yeah, hi, hello. I wanted to bring this topic because we've discussed it a couple of times in the past, and I think at some point we got stuck on discussing the implementation details for ambient mode for this feature, and that's why we didn't make progress on the feature itself. And recently, I was convincing guys from Microsoft, and I wanted to bring that once again to ask you for approvals formally, as I would like to start. I would like to start working on it initially for sidecar mode, and since we are not 100% sure how it will work for ambient, we might do that as an experimental feature, and stabilize it when all kinds of connections will be implemented. I mean, in ambient mode, when traffic is initiated by waypoint or Z2Node, and so on and so forth. So, what do you think? Can we go with that? From the API perspective, that will be just labels for gateways and nothing else.
So I haven't had a chance to look at this doc, Jacek.
Okay, so let me. Sorry for not introducing you. The general idea is to allow is to the cross-network egress gateway is the concept that allows you to route cross-network traffic through dedicated egress gateways, and the reason is if you have standard deployment and you use egress gateways because you want to route traffic through dedicated nodes out of when traffic leaves cluster, you apply network policies and everything works great. But when you scale your mesh to multiple clusters, you no longer can preserve those network policies because in multi-cluster you don't have automatic option to route through these egress gateways, right? Because Istio discovers remote east-west gateway and it uses its IP instead of as remote IP, and the feature will allow users to mark egress gateways, dedicated gateways, as cross-network egress gateway, and then Istio will choose these gateways to route traffic through them to remote ingress and to the actual destination. It's so the general goal, high-level goal, is to allow users preserving network policies and routing through dedicated nodes in multi-cluster deployment.
So when you say egress here, you don't mean like egress to the public internet, you mean egress to the other cluster.
Yep. Or the same. Actually, it doesn't matter. It might be the egress used for everything external, or dedicated for cross-network.
Well, let's try to, right, because there are different, like, I understand like NAT gateway and things like that as concerns for external egress. But maybe we could just focus on the multi-cluster use case for a second and then expand to the public internet egress case. So I have two clusters on two different networks, right? The existing mechanism, right? The Istio DM1 cluster is aware of the IP of the east-west gateway and will just send traffic to it.
Yeah, that's true.
And that is problematic because that east-west gateway on the other cluster can have a completely floating IP. Is that the primary problem?
No, the primary problem is when you're the client, when the client let's say we have cluster A and cluster B, and for some security reasons you want to configure your clients in cluster A to be routed through dedicated pods on dedicated net nodes. You know, if you deploy egress gateway, it sometimes must be that dedicated node, and that's why you need egress gateway, right? And in multi-cluster deployment, you cannot do that automatically. In single cluster mesh, if you reach out to external service, you can apply virtual service which route traffic from pod to the egress gateway, and the egress gateway connects to the external service, right?
Mm-hmm.
And you can do that in multi-cluster deployment because Istio decides that it will use east-west IP for remote endpoints. And this feature will allow to choose local egress as the the egress for leaving traffic in multi-cluster deployment. So we will have additional proxy on the request path, but you will preserve those security policies. Keith, go ahead.
Yeah, I've got to need to drop here in the next 2 minutes, but just quickly wanted to say I'm in favor of this. I think for both the ambient and sidecar side, the implementation looks right. I'm convinced by the use case. I think I see this a lot at Microsoft where there are customers who want for like a firewall reasons or things like that to have all traffic leaving through dedicated nodes in the cluster. With Istio multi-cluster, you can't do that because the sidecars, the Z tunnels, whatever, are on whatever nodes, and they're going to be calling out to east-west gateways outside the cluster. So from like a pure like L4, L3 network topology, this design allows you to still keep those guarantees that you have pre-mesh. Whereas today you have to loosen those boundaries. If you have a network policy stopping all egress from your cluster except through a certain egress point, you can't do multi-network mesh with that in Istio today. This design allows you to keep those constraints. So I'm in favor of it.
Well, let me challenge, Keith, I know you have to run. I'm going to challenge this a little bit. Right, again, I see similar discussions quite a bit. I'm not sure the problem is that we have, or the way to solve this problem is that we require two proxy hubs. I think the problem might be an API problem around how the IP of the east-west gateway is consumed between clusters and how it's materialized, which is a different thing. And let's say for sake of argument, right? Cluster 1 is on VPC 1, cluster 2 is on VPC 2. It's multi-network. The east-west gateway resides in cluster 2, but its IP is exposed in cluster 1, right? That IP could be exposed depending on your, in a whole variety of different ways, right? It could exist in an outer VPC that both VPCs are inner VPCs of, and it's NATed. You could use something like a private service connect mechanism, right, where the IP, a specific IP in one network is virtualized into the other network, right? Or, as you say here, I can put a proxy in the way. They all achieve logically the same effect, which is I get an IP in the network of cluster 1 that points to one or many east-west gateways in the network of cluster 2. Right? The mechanisms are somewhat cloud dependent, but they all offer roughly the same set of capabilities. Right? Like private service connect mechanisms are actually giving you an NLB-based IP, right, for the service in the other cluster materialized into the consuming network. Those IPs are stable and predictable. The problem is the automation inside Istio D, right, doesn't let you interpose those mechanisms into the flow. I can't say when I create an east-west gateway in cluster 1, I don't get to control how that IP is materialized when I create in cluster 2, how that IP is materialized in cluster 1. It's not that we need another proxy, it's we need a way to control how the IP is made visible.
Sorry, I'm not really I'm not sure what you mean by materializing.
So imagine instead of creating another proxy, right, I use NLB, or like your cloud vendor's equivalent of NLB. So in cluster 2, there's an east-west gateway or a replica set of east-west gateways. They have IPs in the VPC of cluster 2. In cluster 1, there's an NLB with a VIP that proxies all traffic to those IPs in cluster 2's VPC. Right? That feature roughly is known as private service connect across all the clouds. That's how that works. It does not require the existence of an L4 proxy or an L7 proxy to be materialized. It's an intrinsic feature of the network. And because it's got a VIP, it has a stable IP. It can have tags put on it and tied to firewall rules and all the other downstream stuff that the various firewalls in the clouds offer. So I don't have to actually run anything to make that work. Does that make sense?
I'm not sure. I don't know. I don't think this applies to all deployment types and all infrastructure possibilities. I mean, sorry, but I don't really get how what you explain is pretty clear to me, but how does it how is it opposite to what I propose?
It doesn't require the user to deploy a proxy or us deploy a proxy. Right, so like Mike, just looking at your answer in the chat, it achieves the exact same effect. It does provide a stable IP and stable egress IP.
Okay, but this assumes that your infrastructure has this capability.
Right, so let's, like, all the major clouds have this capability, all of them. On premise, you might have a different problem, but the solution there might be to use node port for the egress gateway in the other cluster rather than trying to create two proxies. Again, that would have, depending on your firewall implementation and mechanisms, right, stable IP. Right, I could run the egress gateway in a reserved node pool in the other cluster.
I do think that there's a slight topology problem when we start talking about more than two clusters. Like Louis, what you're saying makes total sense in terms of utilizing private connect across two clusters in a multi-cluster deployment, multi-network deployment. When you start talking about 10, that's 100 private links, which tend to not be inexpensive. So having the ability to, rather than saying like our current network topology is every proxy needs to have access to every east-west gateway in a multi-cluster, multi-network deployment. Being able to say, I'm going to designate one call it a multi-network egress gateway per cluster, and only that pod needs to have access to the remote east-west gateways, does seem like a better network topology. Does that make sense?
Right, so that's a different issue, right? Like, I talk to customers about both of these options, right? You want an egress gateway load balancer Right, so today, right, you're correct, right? Like it's N-way, right? And that can complicate policy, for sure. Right, and you're right, like going to hub and spoke for egress gateway can limit the blast radius into the firewalling rules, right, and node labeling, all that kind of stuff. So you're completely correct on that point, right? But it does radically increase the complexity of the system relative to what we currently have in open source. That egress gateway pod has to be able to load balance to all of the actual ingress east-west gateways in the other clusters.
I guess I was envisioning,
Does.
maybe I've misunderstood the proposal. I was envisioning a system where the source, Z-tunnel or waypoint, still makes the load balancing decision. The egress gateway is simply used as like a next hop in order to get to the already chosen destination cluster. So
You're
it doesn't
right.
need to do any active load balancing.
Yes, you're right.
That's my understanding as well.
Okay.
Yeah. So I do have a simple question. So do you expect user continue create virtual service entry? In
No. No, the goal is to avoid that. If you properly label your address gateway, Istio will use its IP instead of east-west gateway IP for remote endpoints.
Okay, so let's say for sake of argument, we're going to go with this pattern, right? Inside, right, the egress gateway has to be capable of performing routing, right, for the service.
Yeah.
Right. So in the legacy sidecar world, that's going to be TLS SNI based routing.
Yep.
Mitch, you said right, that's the only piece of information for in the protocol, which means it has to act as a load balancer. Because right now, sidecars can't possibly pick the backend IP, and there's no way to carry it in the protocol. Not without encapsulation, and we don't have HBone in sidecars.
Oh, okay, I see what you mean.
If it comes to
This is 100% doable with HBone, right, and specifically double HBone, but it is not doable at the protocol level today without changing the protocol.
For sidecars.
Or changing how we encode the destination host information into the SNI header for sidecars.
That's a good point.
I would be more interested in making sure this is possible with ambient because, yeah, like double HBone does lend itself to a topology like this much more easily.
Yeah, I mean, we specifically designed it, including the ability to do egress to ingress, right, for east-west, right? If people wanted to do kind of L4 or L7 firewalling things at the hop, right? It was designed to do this. Yeah, it's much harder with sidecars. Yes, did you look into that issue? Because you said you wanted to focus on sidecars first. There is a way to do it, right? Like we can put the IP as a prefix to the SNI thing, right? But it does require like significant changes, right? Because we use SNI to do this.
But okay, I wanted to ensure that it works the same for sidecar and ambient. I mean, in ambient mode, the egress gateway will not terminate double HBone. It will. Oh, let's start from sidecar. If you have sidecar multi-cluster deployment, currently Istio takes east-west gateway IP and adds to endpoint list of a service. And if you just change it to local egress, it will work exactly the same because egress will route to remote east-west gateway. So
right. So the problem with so that's technically correct, but there's a big problem with this, right? So let's say we perform this. So now we have one egress gateway, right, which becomes the IP that we distribute to all the sidecars.
Yeah.
Cluster 1 is in Europe, cluster 2 is in South America, cluster 3 is in the US. The sidecar can't make a reasonable load balancing decision about which one of those things to hit, right? Because all it sees is there's an egress gateway in my locality. So it's just going to go there.
Yep.
And then the problem will be, okay, that thing has to decide of the 3 possible destinations, which one to send to. So it has to make a load balancing decision. It needs to know how to make it.
Okay, now I understand what I mean.
And the how to make it is going to be informed by basically every destination rule in the cluster.
Well, mostly probably by locality information and look like that's what will come into play. Is like, okay, this cluster is in here. Of the 3 possible east-west gateways, instead of having exposed all their IPs and told the sidecars to make locality-based load balancing decisions based on the locality information attached to the east-west gateways, the egress east-west gateway will now have to do that operation.
Yeah.
Based on its knowledge of either its own location and by next closest hop, effectively, and possibly the location of the pod itself. Right. So there's that. But let's say like we just do next hop load balancing, right? Okay, but we'd have to do that. Right. So there has to be that feature in that type of gateway.
Okay.
Okay, you can make that work, right? So let's say we add that to the design. Then yes, the sidecars will largely not change. Right? TLS SNI is pretty much unterminated. Yep. Right? We'll do next hop locality-based load balancing to the downstream east-west gateways. We have to make sure that information is properly propagated, programmed, right? It's a new type of proxy, yada, yada, yada. Same thing basically true for ambient. The only problem with ambient, right, and this will get worse, there is no TLS SNI. Right, so you'll have to terminate the outer H-bone, especially if you use TLS one.
You don't have to. You can apply the SNI to the
Nope.
to the double H-bone.
Nope. TLS 1.3, we won't be able to do that.
Oh, okay. But why?
That's only going to get worse. So like we're not going to be like, one of the reasons we adopted H-bone is because TLS the 1.3 adopted ECH, encrypted client header, encrypted client hello, and SNI is gone. But we no longer have SNI. And to make matters worse, FedRAMP and every downstream compliance thing we're going to require, right, is mandating TLS 1.3 as of FIPS, whatever 140-3. So TLS 1.2 is dead as far as Z-tunnel H-bone is concerned. Which means we have to terminate outer H-bone and perform the load balancing and then re-emit, which comes with a cost. It's okay, like we pay a cost. People said they want this feature. There's a trade-off in terms of throughput and latency and compute. You get the feature. So, right, and TLS is very fast, right? So we're not afraid of double H-bone. Like we do this. It works fine. You'll now have double H-bone twice. Okay, and in the outer H-bone, we will have lost the originating identity. The inner H-bone will still have it, so that's fine, right? End-to-end is still fine. But any features in the downstream ingress east-west gateway, the egress east-west gateway will have lost some information about the caller when they terminate the outer H-bone. Okay, it's just a feature of the topology choice these are made. That is what we will have. Hope that's all clear.
Okay, so the second part, I don't have an answer to the second part regarding TLS 103, and you've mentioned encrypted client hello, right?
Yeah, so basically TLS 1.3 is removing plain text SNI from the TLS protocol.
Okay, so at the moment I don't have an answer. If it comes to the first issue in the sidecar mode, where you have one egress gateway locally, and let's say 3 ingresses remotely, you can duplicate local egress IP to enforce equal load balancing. Let's say currently, if you don't have egress gateway, and the remote east-west gateway has 3 IPs, the client will have 3 remote IPs, and it will perform load balancing across these 3 instances, right? So you could,
right, but there, I think that's an anti-pattern, right? And it's kind of related to what Mitch was saying, right? Like we could use private service connect as a way to achieve this similar effect, but you're going to end up with basically scaling the number of connections in each client cluster based on the number of egress gateways and all the possible like attached clusters or that are members. And it's non-predictable, right? If I dynamically add or remove clusters, right, I'm also dynamically adding or removing IPs, which is also making me dynamically change my firewalling rules or maintain that system in a greater degree of complexity than I would need. We already have a capable load balancer, right? Egress gateway is perfectly capable of load balancing to the ingress egress gateways in the other clusters, right? And should just horizontally scale. But it shouldn't like we shouldn't create IPs based on the number of clusters there are. I mean, I guess you could do it, but it doesn't improve load balancing doing that. We should scale it based on the amount of traffic that they have to handle.
Actually, I didn't.
Redundancy and resiliency.
Honestly, I didn't care a lot about the problem of equal load balancing because you are not able to achieve that with East-West Gateway anyway, because you have just one, or you have as many IPs as many East-West Gateway pods, but the remote endpoints can be much bigger number than
gateways. Yes, there's a whole other problem which we talked about in the previous meeting about.
I didn't care about the problem that you can have single egress and multiple ingresses, because sidecar mode is not that doesn't solve that in any way. So why this approach would need to solve it?
Not in the sense of the East-West gateways as currently stands are terrible proxies for the number of endpoints in a service behind the East-West gateway. That's a known existing problem. There's a whole other thread about solving for that. It's now we're just dealing with the hop based on what is a reasonable proxy for the amount of traffic going to all the East-West gateways. It doesn't change that problem. And we don't need to create IPs. Like if you're going to have a load balancer, which you have to now have, you might as well let it load balance. And just creating replicas to try and simulate some kind of horizontal load distribution isn't actually going to help. In fact, you're probably better off sending as much traffic as you can through as few load balancers as possible, because they'll make better aggregate load balancing decisions. Constrained on the bottom end by what makes, like how horizontally scaled does a load balancer have to be reliable. But like one load balancer makes better load balancing decision than in aggregate than 10 if it's purely algorithmic. It's just running one load balancer is a terrible idea from a reliability standpoint. Like because one load balancer may just end up with one pathological client, right? And therefore it will skew load. Sorry, if you had 3 load balancers and I had one pathological client hit one of them, the other 2 wouldn't see its load, and so you wouldn't end up with fair distribution of traffic. Whereas if there was one load balancer, it would, right? So in general, our approach is let load balancers load balance when they can, right? And don't try to kick that downstream. It's actually like that's why waypoints, like, and this came up with a large client of ours at Solo. Waypoints and having an intermediate proxy, because they had really high M by N's, they had to introduce an intermediate proxy to get good load distribution, because they had radically different loads coming from the clients. Right? And so they weren't getting fairness of load distribution by having sidecars perform load balancing. Anyway, so that's, I guess what I'm saying is, I buy the argument about wanting to have an egress. If we're going to have an egress, let it load balance. Let's address the issues. We're not going to resolve the downstream issues of like endpoints through the East-West gateway and the remote side not being fairly weighted. That's already an existing issue. We're going to have a whole other thing to address that or not, and maybe an ambient only or not. And then because of the nature of ambient, if we're going to do the same thing for ambient, it will have to terminate out or HBAM. That's it.
Okay.
Everything like that will give you the properties that you want. You get an egress gateway, fine. Those are the costs of doing that business.
Let me just explain something. Since you started explaining how it could be solved in specific VPC deployments, and I understand that you have that your approach is correct. You know that it could be solved on the infrastructure level, but sometimes in some organizations it's easier to do that on L4 than on lower layers, and
no, I buy the argument for why it's a viable thing that we should consider offering. I buy that argument.
Okay, I just want to.
I just wanted to make sure that people didn't think it was the only way of solving the problem. Which the problem being, how do I get predictable IPs so I can use infrastructural firewalling? Right, there are other ways to do that.
Okay, I will consider that, and I will try to find an answer for your concerns. Thank you for feedback. So I'll bring this topic in the ongoing weeks.
Yeah, I mean, just to be clear about it, right? Like one way, right? If all the egress gateways have IPs, I set up an NLB in the source network, configure it to point to all those IPs, right? And maybe tell it to locality load balance to those IPs, because the clouds often have that feature built into their L3 load balancers. And then it would distribute load. And the NLB would have a predictable BIP, and the firewall rules could be attached to it, and that would work. So, and like, if we're going to build this feature, we do at least have to document that that other option exists and why you might choose between them and in what context, right? We have to give a bit more guidance than saying this is the only way, because it's definitely not the only.
Okay, thank you. Thank you very much.
Now, there's a configuration gap, right? Because the existing east-west gateway discovery mechanism and IP distribution and everything else is the only thing Istio understands, right? And so while there may be, the other way exists topologically and physically, it doesn't exist in a way that Istio understands it, and so people can't use it. That's the other problem. And maybe that gap needs to be filled, not just the network path gap, but what the hell Istio understands.
Okay, I will try to think about it.
So I guess we're over time. I really appreciate the conversation. Like, it was very instructive. I've sadly spent a non-trivial amount of my time dealing with these issues over the last 2 years. So I'm quite familiar with them. But I recognize that this is it's certainly a valid way of approaching it and has value.
Thanks.
Cheers. Thanks.
Bye, y'all.
Bye-bye.